Welcome back, everyone, to part two of the Opsani webinar, talking about the unholy alliance of Kubernetes and Java within the enterprise. I'm Amir, Sharif, and with me, I have two of our distinguished engineers, and I let them introduce themselves this time. So, Peter.
Hi, I'm Peter Nickolov. I'm Chief Technology Officer and co-founder of Opsani.
And I'm Pavel Georgiev. I work on the product team of Opsani. And that's probably a good time to talk about what Kubernetes brings to that picture, because everything that Peter said is true for Java in general, but then you add Kubernetes on top of that, and it goes downhill from there. So for a Kubernetes application, you have things like the heap size for Java and a bunch of other parameters that you need to specifically adjust to the available memory on the system. But then for a containerized application, one of the benefits of containers is you can quickly adjust resources of the container as a whole. Well, now you have two places you have to adjust, and that creates kind of an additional barrier to entry if you want to optimize that Java application. And now you have to set the container memory, then adjust the Java heap size to that container memory. And then in large organizations, these may not necessarily be controlled by the same group of people. So it's just a slightly more involved process. And it's something that we provide an extra value by essentially abstracting these parameters as a set of tunables or knobs, and then just changing them in tandem.
Okay, and that goes back, sorry, Amir, that goes back to your original question of the, when did it come that Java started running on Kubernetes? And there is a miss, as Pavel pointed out. Java has been designed to work on large systems, sharing memory and resources with lots of other things. And containers don't work this way. Containers are extremely well encapsulated applications. So, and Java hasn't fully been adapted out of the box to run this way in containers. So what typically happens is that developers, to decide how much memory it needs, they just increase the memory until they stop getting out of memory exceptions, until they stop getting in kills. And what this means is that in the default implementation, Java takes about a quarter of the physical memory available. So you may end up with 4 times the memory that you really need in order to run out of these. So as Pavel said, there are some specifics to running Java in containers and Java in Kubernetes specifically. And our product with the machine learning can make these correlations and also make sure that the parameters that need to be correlated, like the total amount of memory given to the container versus the heap size settings, they're not one-to-one. If you give it 5 gigabytes of memory to the container, you can give 5 gigabytes to the heap. You have to give less than that, but not too much less. So there is a tight correlation there that needs to be met for optimal configuration, for optimal performance and optimal memory utilization. And again, those are things that would be excruciatingly complex to either code as an algorithm, as deep like if then else, or to try to kind of manually tune by hand.
Okay, now for some of the technical members of our audience, it may be useful to explain our mechanism for tuning a Java workload that's being orchestrated by Kubernetes. Because that if somebody's thinking about it as like, gosh, there's the cloud layer in AWS, GCP, Azure, whatever it may be. Then there is the Kubernetes layer that may be managed by the customer himself, or maybe a purchase service. Then there's a Java workloads within itself. And somehow Opsani comes in the middle of all this. Can you explain, and Peter, rather Pavel, will start with you. Can you explain how Opsani traverses that entire stack and provides that tuning in a way that makes sense for the developer while not disrupting any lives or disrupting any release schedules?
Yeah, sorry, what was your choice of commentator?
What was my choice of comment? That was you.
Oh, okay. All right. Excellent. Okay, so there's a couple of ways where we integrate with the system. So typically when you run a Java applications, those settings that you can configure on the Java runtime, these are usually passed as command line options to Java. So when you're running a Java in a Kubernetes container, Opsani has the ability to essentially modify the command line that runs inside that, the Java command line that runs inside that container. So we can discover what your current settings are, which we refer to as baseline, and then start modifying these to essentially go through a number of cycles and figure out what the optimal set of parameters for your application are.
And the way this ties with your existing deployment pipeline is that we essentially use the same mechanism that you use to roll out code changes. Opsani uses to roll out configuration changes. So whenever we want to try a new setting or new resource parameter or new node type, all of these end up being essentially an update to, let's say, a deployment object in a deployment resource in Kubernetes that just rolls out the new configuration the same way, exactly the same way as it rolls out your new code commit. So because we use the same mechanism, that means that those changes become natural and work the same way as your team already works with deployments. So that ensures the continuity, non-disruptive approach, and that it fits within your deployment model.
Yep. If you have an application that can be zero downtime upgraded, then we'll fit in right in this model, and we can make these changes to your application without disrupting its availability. And in fact, we have a mode where we do that on a production app or on a portion or tiny slice of your production app with your production traffic. So as long as you have an application that can be upgraded with zero downtime, then you can use Opsani.
So get a little bit more granular and tell me that now you know what the baseline is. Somehow you've discovered the optimal setting. How does that get pushed back in the code? What's the mechanism for that?
Right. So we give you two ways to do that. One is anything that we find as an interesting result is available through an API. So at any point, you can go and query the Opsani SaaS service and say, hey, what's the optimal setting for service ABC? And then the other way is we give you the ability to configure webhooks. So whenever we find an interesting configuration, which may be the highest performance or the lowest cost or the most efficient configuration, we can call that webhook and tell you, hey, we found this configuration that is the most performant, least expensive, and so on. And you can hook that up right into your CI/CD system to go and roll it out.
And we also have an additional mechanism that allows you to auto-promote settings. So whenever we find a setting that is sufficiently better than your current one, and you can define a threshold of, let's say, 5% better or 10% better. For many applications, we can auto-promote that and essentially take the best settings that we have found and then apply them across the full application. And continue to do that as your traffic pattern may change, your code releases come out and then change the behavior. So that auto promotion effectively eliminates the need for anyone to worry about that configuration and keeping the application optimal.
All right. Now we've talked about how we optimize or how we determine what the baseline for the Java workload as orchestrated by Kubernetes is. We know how we push the changes back into the code. The question that I'm sure a lot of the audience has is, what are you optimizing against? what is the pattern against which you're optimizing?
Well, optimization is always a balance. And that was actually a really good question because we really haven't talked much about it. So especially when we talk about resources, the answer is obvious. You give more resources, you get more performance, or usually you get more performance. Of course, so the obvious answer is optimal is the maximum possible resources you can give it. So in order for that not to be always the answer, we take into account cost. So the optimization always is a balance between performance and cost. That's why one of the most common optimization types that we do is optimize for minimum for a given service level objective for your response time, and give me the lowest possible cost that I can still meet that response time. We also have other combinations. So you may look for the highest efficiency, which is the highest performance, let's say request per second per dollar spent. And that matters a lot when you have a horizontally scalable application that may go to hundreds and thousands of instances in order to be able to use traffic. There, what you really want to optimize is the most efficient single instance. And sometimes that may be a small instance and you just need more copies of it, or sometimes it may be a large instance and you need fewer copies of it. But the balance always ends up being performance versus cost. And also not to miss that, the error rate. So there is a number of errors. Sorry, I have.
No, go ahead. I think that
Yeah,
was...
the balance is typically performance and cost. So these are the two key parameters. There is an additional parameter that we always take into account as well, which is errors. So depending on the application, sometimes error rate is important. And there is a way to weave the application error rate into the service level objective. So what we are always optimizing, so then the way I would state this is you're always optimizing a service level objective versus cost. And so as long as you meet the service level objective, we're looking for the lowest possible cost. And if there's multiple configurations that work that have different results, we always get the one that fits the service level objective the best.
Very well. And so in terms of the load that comes in, I understand that we work with both load generators and in canary environments. What is preferable and what are the best practices that you would recommend to a customer?
Well, from our point of view, preferable is what the customer has. So we try to work with what's available for a particular application, and we don't, strictly speaking, have a preference on one versus the other. So just to dive in a little bit into what the two separate modes are. So if a customer has a copy of their application that they run in a separate environment, whether that's test environment, staging environment, and they have a way to simulate load, then we can use that and kind of adjust the application and also preferably adjust or rather ask them what type of load they want to optimize for, and then make our experiments and give them the result that is valid for this particular load. And in many cases, they actually want to optimize for different levels of load. So let's say they have a European and a US data center. These may be running the same application, but they don't necessarily get the same volume of traffic. So when they talk about optimization in their staging environment, they want to know, okay, what's the optimal setting for this level of traffic and what's the optimal setting for this level of traffic. The other mode is the canary mode, where we take a small portion, like typically 1/10 or smaller of your production traffic, and we change settings on that portion of your app only, and we measure how that compares to the rest of the application, and we are able to essentially find the optimal configuration for that particular part of the application, and then promote that to the rest of the application when we find something that matches your expectations.
Yeah. So as a result, we can do it with test traffic, and that may be simulated traffic or recorded and replayed traffic, and we can do it in live traffic, where we work with the real traffic, which we know is always representative, and then we have additional features that ensure safety and kind of reduce the probability of errors being injected during that process.
Well, guys, we're drawing towards the end of our time. I'm really grateful for what we've discussed here, and hopefully our audience will find it useful and educational. We've talked about the unholy alliance between Kubernetes and Java within the enterprise, what optimization for that means, and what the black magic is, and why it makes sense to deploy a machine learning technique for optimization versus human learning because of the various permutations. And you've gone through some of the best practices for updating workloads, as well as best way for determining how to optimize, whether it's their load generator or the canary environment. And I think, Pavel, well, I love what you said, which is the right way to do it is the way the customer prefers you to do it. So that's the right answer. And I do wish we, at some point, we and everybody else that's hearing this gets to be in close physical proximity. I miss seeing you guys on a daily basis in the office. And the funny thing is, I used to watch CNN, and there were a bunch of different talking heads. I think they were just preparing us for COVID.
Yes, and we can then have a common background, which we are different people in different places of that background.
Well, thank you guys so much. And this wraps it up for this episode of Opsani's Technical Webinars.